Hello everyone, I'm Jason Georgi, Field Chief Technology Officer for Palo Networks. I'm here to talk to you about SASE, really, and why AI matters when it comes to Secure Access Service Edge. So for those of you that are unfamiliar with SASE as a concept, I'm going to provide a little bit of an overview, so I apologize if this is redundant for some, but I want to make sure everybody's grounded in what we're going to talk about today and why it matters, right? So the way I see it, we're talking about a new convergence. At first, when SASE was announced as a market or a technology segment, the whole idea was converging network and security at a cloud edge in order to provide better outcomes for customers around cybersecurity and networking. Now I think that's evolved, right? And we'll get into that a little bit here. Before I do, though, I want to set the ground rules for the conversation, right? Which is the way we should be thinking about things when it comes to Secure Access Service Edge, right? Or how people are working. And that is, work is an activity, it's not a place. If we allow something like that to ground our conversations around technology moving forward, it just makes things so much simpler, right? Because if we think about how things have evolved over the last 10, 12 years with cloud and mobility, the idea is, how do we achieve better results for our employees, reduce risk in our organization, and think about what the guardrails were that we had in place long ago. Right? So if we go back just a little while, pre-pandemic even, before accessing a lot of resources, most employees went into an office, they badged in, they authenticated to a wireless access point or a network before even being able to access a single resource. Those guardrails go away when employees are sent home. Right? So now how do we ensure consistency of security posture, policy, and reach now that these users are hybrid workers or fully remote, right? It's ensuring that we have the same level of security posture even without those guardrails in place. So that's what's changing what we have to think about when it comes to network security and just security in general, right? Is the assumptions are gone. Users can work from anywhere. And so we have to be able to account for that. So looking at this reality now, okay, that we're removing place and we're saying it's an activity and it could be done anywhere, we have to look at risk in two ways for most organizations. And this starts with security, right? Preventing threats. That's what we're in the business to do, is make sure that no matter what's happening, we're able to take a look at this from a threat prevention perspective, protecting users, apps, and data, no matter where any of those are. So users that could be working anywhere, whether they're at home, in the branch, or traveling, to resources no matter where they are. Data centers, colos, cloud IaaS or VPCs, SaaS or the web, it's protecting the users, the transport to that destination and the destination itself. But equally as important, right, especially as we start talking about how certain traffic is now moving through these types of services, is operational availability, right? Making sure that we have the scale in the platform to accommodate the resilience that we're thinking about and need. Let me put this in an example for the networking folks out there, right? When we design office locations and branches, depending on what's going on at that branch and the tolerance for fault or disruption is how we design connectivity, right? Dual MPLS circuits with an ISP backup, and then that evolved a little bit as ISP became more reliable to maybe, active MPLS and ISP, whatever that is. But we ensured that if there was critical traffic coming from that branch or going to it, that we had the resiliency to support that to minimize any disruption of outage or downtime. The architecture now is shifting to the cloud that provides that service, right? So if we're sending mission critical, business critical traffic through this service, it needs to be just as resilient, right? So we're talking about things like multi-cloud. We're talking about things like availability zones and things like that. So I'll talk about that a little bit more later, but this is what we have to be thinking about. Cybersecurity around threat prevention is absolutely one aspect and usually the primary one that we have to think about. But when it comes to the service being used for transport, the availability of it is just as important. The other aspect of this is, well, okay, why should I care if I'm a CISO or a director of cyber? Because you're putting programs in place. And if you have a lack of resiliency or performance through this particular service, doesn't that make your employees want to bypass things a little bit more, right? So now we've got a circumvention of all the security tools we're trying to put in place because the cloud or the service itself isn't performing the way we need it to. So it's ensuring the users can be productive and do their job without interruption. So let's take a look at this in terms of outcomes and outcome delivery. As I said before, to open this up, there's a security element of this, obviously, protecting users' apps and data. That's what SASE is really meant to solve initially, right? But then when we start thinking about, okay, what else can something like a platform that's doing this solve for us? Well, what about simplification? If we're rationalizing our estate, I'm going to take another step back, right? So start with rationalizing the estate and where we want to go from here. Take a look back, and maybe some of our environments are still this way, but how many tools did we have providing access? And let's think of one use case. Remote users accessing data center applications or cloud applications. We'll call them private apps, right? Could have a VPN, software-defined perimeter, VDI infrastructure, all of the above, right? All two, three, maybe 4 tools, depending on your organization, trying to solve for the same use case. Now throw in secure inbound access from third parties, unmanaged devices and locations. What are the tools we have in place for that, right? So is it a matter of being able to get better at what we're trying to do by simplifying our environment? Because simplification creates better outcomes, right? The less we have to manage and orchestrate and ensure policy is in sync between several different disparate tools from different vendors usually, the easier it is for us to stop something bad from happening. If we need to make a policy change, we make it in one place, and then it becomes pervasive, rather than, did we change policy here? Did we change policy there? Are we safe over here? What tools are securing that traffic, right? So it's a matter of taking a look at what's just providing access. Think about the secure outbound side, right? A lot of organizations are using a secure web gateway or a proxy of some sort to access web applications. For those internet applications that aren't web-based or need, some source IP anchoring and things like that, now we've got an application gateway sitting somewhere as well. Both outbound internet gateways, but serving 2 different functions, often 2 different platforms and architectures, right? How do we simplify that? Now we start thinking about SaaS and other capabilities around that. It becomes very complicated when all we're talking about is access. So if there's something we can do that gets us into a better, more productive place from a management and supportability perspective and a more secure perspective, that's what we should be focusing on. So this gets into the whole, we've got users, again, working from anywhere, whether they're at home, in the branch, or on the go, accessing both private applications and data centers, VPCs or colos, and public applications sitting in SaaS or the web. How do we make sure we get convergence around that? Just the platform itself. And then there's improving user experience, right? So as we shift services to the cloud, this is no different than our IT counterparts try to solve when moving compute services and applications from on-prem to the cloud, right? They were looking for different things. They were looking for elasticity, perhaps. They were looking to do data center consolidation, but it couldn't be done in a way that actually decreased performance, right? Created a poor user experience. A lot of those projects that did, as they started down the path of cloud, wound up being paused or shelved completely if user productivity took a hit, right? Because the whole idea of business is to stay agile and productive, right? If users and our employees can't work, they're not delivering our products and services. So we need to ensure that user experience is good as these services move from on-prem to off-prem. No different when we talk about network security architecture, right? We need to ensure that we have the ability to provide at least as good, if not better, of a user experience as they are now mobile and working from anywhere, and their workloads could be absolutely anywhere. How do we ensure that happens? And that's based on the cloud architecture itself. What can the cloud do for you, right? So we'll talk about that a little bit as well. What I want to start with, though, is grounding us in the security piece, right? Because this is what we're here to talk about, secure connections today. But when we start thinking about what a lot of the tools are out there around securing inbound access, right? Secure inbound access, secure private access, things like that. We are continuously seeing zero trust network access approaches that are they're falling short, if you will. And so what I really think we need to do is get serious, okay? And I say this in a friendly way, but it's only because I speak to customers all day, every day, and I continue to hear things like, that's good enough. It checks a box. Well, how is that responsible when we're talking about cybersecurity? We're not talking about commoditized networking equipment. We're talking about protecting our users' apps and data, right? So is there a better way to do that that's going to achieve a better security outcome? Because really, checkbox security, good enough security is just no longer good enough. So let's explore that a little bit. When we start thinking about zero trust and zero trust network access, right? Regardless of what you may hear from certain vendors, the idea of zero trust is just to eliminate unauthorized access, right? It's an explicit deny type architecture that says we are not allowing anything by default. In order to access a resource, you must be authorized, right? We must go through a process to say you are who you say you are, and based on who you are, the device you're coming from, there's a set of entitlements that you get, right? Based on policy. So now it's an explicitly allowed access posture, right? And this is important, right? So let's walk through this a little bit. When we think about zero trust network access, two questions by default have to be asked. Who? Let's start with the who. It's pretty simple, right? Who are you? Tell me everything I need to know about you. Full context, right? Your authentication status, your group membership, everything I probably need to know about you in order to start making some decisions. And then, what type of device are you coming from, right? Is it a managed device that's fully patched and up to date? Or is it unmanaged device, whether it's BYO or something else, or is it a managed but high-risk device because it hasn't checked in a while, right? What is the context of both now the requesting user and the device they're coming from? Those things together, we need to understand to complete that question of who. Good or bad, right or wrong, we have context. Then we can ask what. So now based on those variables that could come with who you are and what device you're on, what would you actually like to access? First of all, is it allowed, right? Let's start simple. Is it allowed, yes or no? Yes? Okay. But let's take a deeper look at that. Based on that yes, what about those variables do we need to check on to ensure that you should have the right level of access? Because this is another part of zero trust, right? Least privileged access. And least privilege doesn't just always mean based on your role. It could be based on variables like your location. For example, I like to pick on myself all the time. I'm Jason, I've got my managed device, I'm working from a known location. I have full access to all of my entitled applications. I take myself and my managed device to the Bahamas on vacation. Palo Networks, certain other organizations may say that's a high-risk location. You can have access to certain applications, but at what attribution, right? What level of access should you have? Instead of being upload and download access, right, because it's higher risk, maybe you only get read access to that particular application. Okay, fair enough. That's all I need given that context to actually do my job in that location. So it's got to be adaptive, right? So it's asking the who and the what, but once that what is being asked, at what level, right? What level of access should be granted? You could argue in a lot of ways that most zero trust network access, zero trust architecture vendors are trying to answer these two questions. Identity is the new perimeter, right? And so identity-based access to applications, adaptive-based policies, fair enough. The challenge that we continue to see across the board is not enough of the vendors asking one and two are asking the third, which is what's inside. So, okay, fine. I'm going to grant you access based on your entitlements, right? Your entitled access to an application. However, what happens when that access becomes malicious, right? You have it by policy. And so let's draw this out, right? Let's think about what could happen when access is granted via policy without another check of that traffic, right? Which is compromised users, right? Now, compromise can come one of two ways one of three ways, actually. One, it could be, a malicious external user, right? Your outsider threat that's trying to steal credentials. The next would be your malicious insider, your insider threat that's abusing their credentials. The other kind of plays in between, which is your unintentional harm. Somebody that accidentally clicked a spear phishing link, then succumbed to fatigue with an MFA bomb attack, and now somebody has credentials, right? It's not always intentional. Sometimes things just bad things happen to good people, right? We've all seen it. We've had our aunts, parents, cousins call us, say, I think I clicked a link. What should I do, right? So we've been through this. Well, this happens at the corporate level as well. We all know this, right? Any of us that have been in security long enough have seen this happen multiple times. So what we really have to do is solve for the who, the what, and the what's inside. Conventional wisdom that a lot of the SASE players take in this, or even let's subcategorize that into the security service edge, right? SSE. They look at it in a different light. They say, you know what we're going to do? We're going to protect users from the internet, right? So if we look at this as an A-B relationship, the user's A, the internet's B. We want to protect A from B, all of those threats. So we're going to do good internet security because the bad stuff happens on the return traffic. So we're going to do our proxy, our sandbox, our DLP, our IDS, IPS, all on that secure outbound traffic. The logic holds then that if A is then free from threats from the internet, when A now wants to connect to the third leg of this relationship, C, your private application sitting in a data center or a cloud VPC or something like that, traffic should be clean. Right? Because if the user's protected from the internet, the device is clean, traffic sanitized going to, that next location, the private application. That logic falls apart with the examples I gave you: credential theft, abuse, or unintentional harm. Right? So if identity is the new perimeter and identity is compromised, we need to take that a step further. Right? And so we start thinking about even the analogy I used before around we used to physically walk in or badge into a building and authenticate to a network before accessing a resource. If you're an attacker, how do you want to look at things, right? Do you want to look at something as brute force your way into a data center or VPC through an attack? Or is it easier to just go on LinkedIn, find your company target, look at their C-level, gather the list of the C-levels in their title, who's on their legal team, who's on their M&A team, and depending on that organization, that could be 20 people, 100 people, 500 people, right? Cast that spear phishing or a whaling attack, right? A whaling net. And then all of a sudden, all you need is a couple, one or two, to click that particular link. And then hopefully that one person or one of several that did click that link originally does succumb to that MFA bomb attack. Now that attacker has your credentials, and those are highly privileged users, right? So the only way to mitigate the risk of credential theft, abuse, or unintentional harm is to ensure that once access is established, even entitled access via policy, that you're able to look inside that traffic session for malicious behavior. Right, so it's a much different approach. It's not taking, it's ensuring that that A is protected from B, but we're not just going to assume that C is protected from A. We're going to protect C from A, so your private applications from potentially compromised users or devices as well. That's what we need to be thinking about. That's why we ask what's inside. So great, great security, makes sense. I totally understand what you're trying to do here. But at what impact to my user experience? It's what I get all the time. It's why most organizations that still run on-prem services have not turned SSL decryption on, all of their outbound, access and things like that, because it just bogs the services down, right? It's too much. Or if I inject a sandbox inline into my network traffic, it's going to slow things down. So I'm just going to put it in tap mode, right, or monitor mode, and just see what happens and analyze after the fact. When we think about those organizations that were breached over the last going back several years, huge household names, right? They didn't lack security tools. What they lacked was how they deployed them, right? So the answer then to getting ahead of threats and not letting these things fester in an environment for 4, 6, 8, 12 months before they actually start to, percolate and then detonate their payload is to sit in line and block as much as you can proactively. But what that takes is scale. This is now getting into that other side of the resiliency and the cloud architecture. It matters. Right? When we think about what a cloud should look like that's delivering this kind of security at scale for large multinational organizations, potentially hundreds of thousands of employees that are accessing resources at the same time. What does this need to look like? Well, the cloud itself let's start, like I said earlier before. How did we design our site locations that were carrying mission critical traffic or applications? We designed them with resiliency in mind, redundancy. So maybe a multi-cloud architecture makes the most sense, right? Something that actually uses two clouds. Monolithic to you as the consumer of this particular service, but it's actually two clouds, right, that are able to fail over off of each other. And when we think about the use of something like a hyperscaler, pick your hyperscalers of choice, they're all built with high availability internally, right? So each region has multiple availability zones, no less than two, usually three. Some are now adding a fourth, right? So now you've got intra and intercloud availability and failover when it comes to these cloud architectures. So that's going to give us scale, right, and availability, because we talk about hyperscalers, you have near limitless capacity at your disposal. And it winds up being a software change, right? It's not like you've built this cloud that every single month or every couple weeks you're shipping out, server after server after server, new racks to accommodate expanded use by existing customers, but then onboarding new customers to that particular service, where now we could start to see some disruption due to congestion and things like that. If we can ensure that we've got the scale to provide virtual single tenancy in this cloud architecture, does that make you feel more safe? Does that de-risk your move to an SSE or a SASE platform? Usually the answer to that is yes. So scale has to be there. It's the speed of security processing. When you have scale, when you have these hyperscale environments, they can just process security faster, right? What if I told you that all of that security that I was talking about before when it comes to securing traffic back from the internet, so protecting A from B, but then protecting C, your private applications from A, could all be done in less than 10 milliseconds of added latency with SSL decryption turned on? That's the difference, right? It's how fast we can actually process that security inspection and access control policy, making sure that we're introducing as little delay as possible. But then once that processing's happened, how do we get that user to their destination as quickly as possible? The use of cloud networking, right? A cloud fiber backbone. User gets onto the cloud via fiber edge location to a security processing area where all that security processing is done at less than 10 milliseconds of added latency, back onto fiber to as close to the destination as they can, eliminating middle mile variability that often improves performance over split tunneling, right? Or bypassing traffic from your typical security services. That's what a lot of organizations had to do when the pandemic hit, right? They didn't have the capacity in their remote access infrastructure to send all traffic to that service. So they sent what they thought was critical or certain application traffic, bypass that service for the rest. Internet and SaaS applications, we'll deal with that. We've got some endpoint security, we'll be okay. What if that cloud architecture can actually ingest and digest all of this traffic for threats? Does that produce a better outcome? Typically the answer is yes, right? That's what we want to do. We want to inspect as much as we can. We want that to be as fast as it can be. And that is by ensuring that we don't introduce the need or desire to bypass. And that's what the cloud architecture with that performance is going to give us. We can actually provide better performance than traffic being sent through a bypass on the internet itself. That's a win, right? The ability to, I talked about scale before in general, but how about something like auto scaling, right? When we talk about the ability to scale your instance of a cloud as needed on demand. Good example. A lot of organizations, global organizations, every 4 years, there's a very cool event that happens that everybody's interested in, the World Cup, right? And a lot of organizations will allow their employees to stream that traffic at work. This is a passion. This isn't just a game to them, right? This is a passion for them. And so when those types of events happen, when you're using cloud services like this, they're strained, obviously. Now throw in trying to access critical applications through the same cloud service where we already have congestion. And now that's starting to impact user experience, it's starting to degrade performance overall. Most organizations will say, cool, time to shut off that streaming traffic, focus on private application access. Unless you're multi-tenancy in a lot of ways, right? Which you can't quite isolate that traffic across multiple customers, So if we can say, instantiate every customer, as their traffic demands increase, we're going to go ahead and scale up their instance on demand. When the event is over, we'll scale it back down. It's just a scaling event. Nobody has to call in advance to do anything. It's all software-based API calls to increase scale as needed for the customers that need it, when they need it, not impacting anybody else. No other noisy neighbor condition, right? The other example I give is when everybody went home, some that are still working from home in a hybrid type scenario at times, peak times of the morning and afternoon, right? And depending on that day, maybe the kids are gaming, or your spouse or friends are, doing some things, logging on at the same time, or doing a webcast from work, something like that. All of a sudden now the broadband CO closest to our house is congested as well. We may be paying for 800 meg, a gig, 1.5 gig to our house, but how much are we actually getting in those peak times? 100 meg, 50 meg, 200 meg, whatever it is, it's not what we're paying for, right? And so if you're talking about ensuring you have the throughput you need when you need it, that's what the right cloud architecture and scale is going to give you. So that's why architecture matters, right? Ensuring that as security needs increase, as we look at risk in both of those ways, right? The prevention, protecting users' apps and data, but then the operational availability of ensuring we have the scale and performance and good user experience through the service. This is what we get, right? It is critically important that the cloud architecture itself is part of the SASE equation and discussion. So where does this lead us? It leads us to what I kind of opened up with, right? Which I said, SASE was introduced as a convergence between networking and security to provide better outcomes around users working from anywhere, accessing any resource. I think we've solved that problem pretty well at this point. Where we're now seeing a convergence is how can we leverage AI better to amplify those outcomes? The new convergence, in my opinion, is SASE and AI, right? So when we think about why this is important, okay, why should I care about SASE? I mean, AI has been in the news for a lot of the wrong reasons the last 8 months, but a lot of us know that a lot of these security tools have been using it for 4 or 5 years already in a lot of ways. It's to analyze data, right? If you're a security organization like Palo Networks is, we're a data collection company at the end of the day, right? We're collecting threat data. We're collecting networking and traffic data, much like AT&T collects network data, right? We use AI to process what's happening faster and get better results quicker, right? So we can do something about it. So when we think about why AI and SASE go together so well, I would say when deployed properly, and as some of these organizations that are a little more forward-thinking in how they need to solve network security, 80% of customer use cases I'm seeing are solved through a SASE, right? Because you've got that ability to secure those users anywhere they work to wherever they're going. So you're just seeing so much traffic. And if the scale's there, like I was talking about previously, we're not bypassing traffic. So we're getting full visibility to all of this traffic coming at it as a clearinghouse, right? Traffic's coming in, we're seeing it. So threat traffic, networking traffic, whatever it is, we're seeing a lot. The breadth of SASE itself is what's giving us this information. And so with that, that's a lot of data. And in order to do something actionable across thousands of customers from our perspective, right, that we need to report, help them report on and do something about, millions of users, hundreds of thousands concurrently, if not more, we need to be able to analyze that data as quickly as possible and adhere to the 3 C's of data, right? When it comes to AI, data drives good AI, right? And so it's the completeness of the data that we see, making sure, are we seeing as much as we can from where the user or where that traffic was sourced to the destination and every segment in between. What happened? Where did it happen? It's consistent. If we start going down that path of simplification, like I talked about earlier as well, where we're looking at all of those access tools, private application access tools, public application access tools, all of them in our estate, we start to shrink them down into a single platform. Now we've got consistency around the data we see, right? Because these logs are speaking the same language. They're seeing the same type of thing. The access control policy and mechanism are similar to each other. So we get that consistency right out of the gate. And it's correct. Why? Because we're not trying to piece different data sources together and try to figure that out. The industry has built tools to try to help with this, especially those of us that are, in the SOC, teams or those security analysts where we've got our SIM that's collecting all this data, but it's data, right? How are we actually orchestrating a response or doing something collectively across the entire security estate? Well, now we're adding something like a SOAR, right? A security orchestration, automation, and response tool. Great, that helps. But what if we just set ourselves up on a better plane from the beginning, right? And that is by having that correct data that we're seeing because it's all coming into the same place. So this is, it's the analysis, right? It's ensuring that as we see billions of threats, we can analyze them, do something about it, and protect our users as quickly as possible. As we see traffic variation, we see something happening with one customer, it's essentially the same path that another customer is going to take. Is there something we can do to correct that? Or at least proactively alert them that there is an issue, a regional issue with a broadband carrier or something like that? How can we get better at delivering outcomes with the tools that are already there? It's just how fast can we process this information and create something more actionable out of it? That's what we're trying to solve for. So that's the data analysis piece. But this is also how we're going to need to keep up with our adversaries. Right, let's think about that for a minute. Malware, ransomware, they're all kits. You don't even need to be an actual hacker anymore. You can go out in the dark web and just buy this stuff. Pick your target and off you go, right? And a lot of this stuff now that is state-sponsored or even group-sponsored, they're using AI to get better and faster at what they're doing. We have to match that energy. This is not a people problem that we can just continue to throw bodies at anymore. That used to be the answer. Oh, we have more data, we're seeing all this stuff, we'll just hire more people, more analysts to do something about this. We can't keep up. It doesn't matter what organization you're in, how much you want to pay, there's a skills shortage issue in cybersecurity. There are more jobs than people to fill them. And it doesn't, like I said, it doesn't matter who you are, it's hard. So throwing bodies at the problem is no longer an option. The only way we can match the energy of these adversaries is to use AI ourselves and get better and faster at what we need to be able to do. So looking at this is why AI matters to SASE. It's not trivial, right? It is something that we have to be thinking about because, and the reason I say that, and nothing against this audience, I'm sure. Some of the conversations I do have, it's like, whoa, you're throwing around that AI ML thing. Can't I just have something that does the job, but it's a little old school? Here we go. With good enough, it's not good enough anymore. Right? We have to be thinking forward. This is cybersecurity. We're protecting our most critical assets. We have to get better about this. So AI is how we're going to supercharge what we're doing with SASE. Right? All the things that SASE can already do from a security perspective, from a cloud architecture perspective, all great. But the data that comes through these channels, is what AI is designed to help solve and create better outcomes around. Looking at SASE, network security, convergence, right? We do have to think about the rest of it though. Like I said, implemented right, most customers can probably solve 80% of their use cases with a SASE architecture. Unless you're a brand new organization that was born in the cloud, all your apps are cloud-based, but that's a relatively small percentage of the overall, organizational base, especially if we start including governments, education, and things like that. So we need to be thinking about network security more holistically as well. So SASE is a very modern way to address a lot of the shortcomings that previous network architectures had, but it can't do it all. So when we start thinking about, what I just said with a modern way to address it, a lot of customers started thinking for a long time around, well, I've got this good network security in place. It's on-prem though. Can't they just have something that scales, right? So that I can actually push these certain services to an edge for these other use cases? Well, sure, that seems like it should make some sense. But what happened when that started, when those technologies started to, come onto the market and on the scene? A divergence of consistency. We lost the consistency that we had. Before, when we were backhauling everything into a data center for centralized inspection and control, at least it was consistent, right? Now we've got a tool if users working over here, a different tool when users on net, a different tool if users accessing a particular SaaS application. It's all over the place. SASE Convergence helps actually solve a lot of that problem from some of those worker use cases like the hybrid worker and remote branches. But there are certain things a cloud just can't see into. Layers of the data center segmentation, the separation between IT and OT environments, right? These are things that have to be done locally. So when we start thinking about then what should access control look like, it should look like I'm a user, I need to access an application or a resource. It doesn't matter where I happen to be, even if I'm on net and that resource is on net as well, the same access control has to be there. The same consistency has to be there. And if I wind up getting compromised in much the same way I talked about before, the ability to protect that traffic has to be consistent as well. So this is where we start saying you need a more holistic approach to network security where you're consuming that as the idea, securing network traffic, no matter where it is. And now you just use the right form factor, whether it's a hardware firewall where you need it in data centers and certain large campus environments, a software firewall like a VM in small branches that have that IT-OT separation, or your VPCs in your cloud as your VPC front door, and SASE for the rest, right? Your remote workers, your hybrid workers, and your remote branches, right? But it's consistent. So you consume network security, your access control policy, your who and your what's inside, the same way. You just use a different enforcement mechanism that solves the use case best. So it should be multidimensional, right? Holistic, zero trust architecture plays right into that, right? Because if we're talking about that who, the what's inside, now your zero trust architecture is consistent across the estate, right? It's not, we're trying to match something up, we're trying to piecemeal this together, we're doing the best we can to orchestrate what this needs to look like from a control perspective. And it should be use case driven. You shouldn't be forced by an SSE, a pure play SSE or SASE vendor to say, well, this is what we do, and in 5 years, you're never gonna need another firewall. These guys have been saying that for 15 years. They're still out there, right? So the reality is they are still needed, and where it makes sense, they should be used and deployed, right? Because it does make sense in other use cases that the cloud just can't properly address. So I can say what I want. You've listened to me talk now for 40 some minutes, but look, we've got some validation behind us, right? We pride ourselves on not only delivering good outcomes and capabilities to our customers, but also being recognized for that, because a lot of this feedback does come from customers as well, right? Interviews that these analysts wind up doing to say, how good are they doing? Are they solving your problems? So leaders in the SSE quadrant, leaders in the SD-WAN quadrant, and the only leader in the single vendor SASE Magic Quadrant from Gartner. So when we talk about what we're trying to do, we mean it and we back it up, right? So in all, I would say, maybe months ago, we would say something like the future of SASE is AI powered, but the future's here. This is where we are, and this is what we can solve for. So with that, I've concluded my presentation to you all. I hope it was valuable. Now I'm going to open it up for some questions real quick.
All right, I've got a few questions here. So
Great.
The first one, what are the pros and cons of using a single vendor SASE solution compared to building a custom solution?
Okay, good question. And I hope some of this that might have been submitted before the discussion, and this is clicking a little bit more now. Mix and match, build your own SASE was an idea that I heard a lot about when SASE was first talked about, right? Hey, I like this particular vendor for this capability, this particular vendor for this one. I can do well by orchestrating this myself. We've all been there, right? We all used to come from the best of breed type way of building architectures. There's just a lack of continuity and consistency when we continue down that path today. So it's not necessarily a path I like to see organizations try to go down anymore if we can help them by showing them the consistency of the data that they get, and then using those tools like AI, because now you've got that complete consistent data coming through that's correct. So you get better outcomes when you start actually consolidating this down. The pros would be of a build your own is just familiarity, right? So if you have familiarity with one particular product that you really like, that could be a pro, because again, it's a skills and learning issue in a lot of cases, or just talent. However, if you have any of these other components in your environment that have the same skills, whether it's firewall management or something like that, and now they can just extend the same capability to the cloud, you're not losing there either, right? So that, there's pros and cons to each, but I think all of the pros of a build your own or do it yourself can be countered with a pro of single vendor SASE.
All right, and then are there any behavioral analytics used in detecting bad actors across a SASE system?
There sure should be. A lot of SASEs, either whether they call it out or not, are using some type of XDR as part of the solution, right? So they're, by seeing these threats come in or seeing an anomaly, right? Seeing some type of behavioral change, and that could be the user's behavior, or it could be how the application's being accessed. That's the point of running something like full content inspection in line for even private application traffic. Because if you've got something that's doing that continuous check, right, that who and the what, continuously saying, all right, I know everything about you, application access is granted via policy, but if you just allow and ignore, so you do that check once and then the user's off and running, even with security inspection, that can't account for changes in the user behavior, which could be an issue. So the who and the what has to constantly be assessed. We call that continuous trust verification. If the user behavior changes at any point in that session, what do we want to do about that? It's a policy call. Do we terminate the session, force a relog in, or quarantine that user till we figure out what's going on? So there should be some type of check and balance in that. If your SASE doesn't have the ability to do that, so say it's relying on a partnership or an integration with an XDR, that's a challenge because now you're dependent. It's not just a defense in depth mechanism. You're dependent on that XDR to be, one, running and operational, and two, doing what it needs to. Where that tends to be an issue, like I talk about things, arguments for things falling down, unmanaged devices, contractor third-party devices accessing the same applications or services, you may not be able to tell that unmanaged entity to put the XDR you have an integration with on that endpoint. So now what do you do? So you need to have something that's built into the SASE that can do as much of that as it can.
All right, and then can data from a SASE system be used to attribute actions to individual threat actors?
Repeat the question, I'm sorry.
Can data from a SASE system be used to attribute actions to threat actors?
It should be. If you're starting to leverage something like a well-rounded IDS IPS capability, so ours is called Advanced Threat Prevention. It's not only understanding what it saw from our own sandbox, right? So unknown threats that we create a signature for and push to that for prevention, but it's also bringing in feeds from other things. It's seeing other things that it should be able to then say, okay, recognize this once, let's enforce it now cloud-wide, right? So that's a cloud effect we can get. So all of those, types of threat identification and then application of security should be, one, there. For us, it is at Palo with Prisma Access and the services that we run. But then two, once it is there, how fast can it actually enforce and protect? If you've got something outside of a minute of SLA around pushing these signatures down or enforcing that security, you've got a real problem because it doesn't take that long anymore. So making sure that you've got not only fast security processing, but that cloud effect has its own SLA that once something's identified, the protection is there and then pushed down cloud-wide in under a minute is where you want to be.
All right, and then if I'm a current Palo Alto customer, why should I consider Prisma Access?
It's a good question and one I get all the time. We started as a firewall company, right? And so we've got 90,000 firewall customers out there around the world. And they're all looking at SASE now, but they don't want to lose, necessarily some of the investment that they have. I look at it this way. Eventually, branch firewalls and things like that will have to be refreshed. What do you actually need them to do if you're able to now leverage a cloud to do a lot of the security processing and traffic handling? Can you scale down what's needed at that branch firewall level? Can you repurpose something? So rather than buying a net new set of firewalls for something somewhere else, can you just take the firewalls that we're doing this edge security or border perimeter security and repurpose them in your micro segmentation, your data center segmentation strategy? Yeah, let's think about that. So it's about maximizing what your existing investment can still do for you until you no longer need it. and then we can maybe just shut some things off. But like I said before, a lot of environments still require physical or virtual but near physical separation around IT, OT environments, the data center segmentation piece, or just even certain regional traffic deployments. So if you've got huge concentrations of users in the same region or geography as where most of their workloads sit, it may not make sense to send that traffic to a cloud. So that's where the modularity of a SASE makes the most sense too, to say, well, let me use it for the use cases that make the most sense. This group of users, these third parties, these branches, but then use other services where it makes sense as well, rather than it being an all or one, where something might fail or not be quite as optimal as it could be using those services. So there's always a way to continue doing that. The final piece around that I'll say is we have a lot of customers that had a lot of branch firewalls around and are using SASE, and what they're deploying is what Gartner even coined the actual architecture around it, but it's called thin branch heavy cloud, which is saying I've got this firewall sitting on-prem to do some of that separation of maybe my employee network, my guest network, my things network, run threat prevention across those VLANs to make sure that everything's clean. But then when it comes to internet access DIA, why don't we let the cloud do the SSL decryption, the sandboxing, the DLP, the threat prevention, for the internet sites and things like that, so the IDS, IPS capability, offloading all of that from that on-prem box. So then I can extend the life of it, let the cloud do as much as it can, and that's going to create a better user experience too, because now I can get the user's end destination traffic as close to that destination as possible, rather than just dumping them off on the internet. So in-branch heavy cloud is another way to maximize the current investment you have without necessarily having a refresh, and let the cloud do the rest.
All right, that's all the questions I had.
All right. Well, thank you all. I appreciate you paying attention and listening to my presentation today.